All right, so we're doing the Unit 2 mix review, and we're going to start with problem number 1. With the projectile motion, it's essential that you draw a picture because every problem's a little bit different, and if you try and do it in your head and you do math, you're not going to get it, you're going to conceptualize wrong. So it says Romeo is chucking pebbles gently up to Juliet's window. And he wants the pebbles to hit the window only with a horizontal component of velocity. So this is actually a little bit different than what we did before. So I'm just going to draw a little picture. And let's say this is the window. And let's say he's over here. And when he's throwing the pebbles, the key to this problem is the final velocity is, this is my final velocity. So what we did before was, before we did problems like this, where it was all horizontal, and then it ended up being like at an angle. Okay? And what we're doing here is, you see it's kind of like reverse. So here, this initial velocity is at an angle. It has both horizontal and vertical components. And now the final velocity is just all horizontal. Does everyone see how it's kind of like the reverse? So we did a bunch of these problems. So this is kind of like the same thing, but the opposite. Okay? But you need to draw your picture because you can't do this without the picture. So let's write our given. We have our x and our y. We're going to always write that ax is 0 and g is equal to negative 9.8 meters per second squared. Okay. Now I'm going to read the rest of the problem. It said he's standing at the edge of a rose garden 4.5 meters below her window. Okay. Now remember, where motion begins, that's my frame of reference. So I always make a big dot. So now if I just go like this, I'm measuring that this height here is 4.5 meters. So y is actually plus 4.5 meters. So the first time I read this problem, I was a little bit confused because it said below. But again, this is my frame of reference. This is where motion begins. And my sign convention is going to be like this. So because I'm measuring really from here up, it's going to be positive. All right, then it says, and 5 meters from the base of the wall. So then when I measure this way, this x is equal to 5 meters. So again, now I'm going to put in my given. And again, in your given, you want to have both positive, you're going to have your x and your y given. And when we have 3 things, that tells us what to do. So the question says, how fast are the pebbles going when they hit the window? Now the key to this is, you see this VF? This VF is actually VFX, right? Because VFY is 0. So do you see how the final velocity has no horizontal, no vertical component? It's all horizontal. So that's the key to recognizing this, and that's when why I showed you this, because it basically is the reverse. Here, the V naught is all horizontal, and V naught Y was 0, and then it went down like this at an angle. So this is just the reverse picture. Okay. Now we can go ahead and do this problem. Well, what I can do is, I can say VFY squared is equal to V naught Y squared plus 2GY. And you know, with all these problems, there's more than one way to do it. Okay? Because you can do different things first and use different equations because we have all our kinematic equations. So if I rearrange this to solve for V naught Y, V naught Y is equal to the square root. Now I know this is 0, so I'll get rid of that. Oops, I shouldn't have done that. Sorry. All right, let me rearrange the equation. I'm solving for V naught Y. So V naught Y, so over here, this is V naught, and I'm going to have V naught X, and I'm going to have v naught y. So v naught y is equal to the square root of vfy squared minus 2gy. So what I did was I took this, I subtracted it to the other side, and then I took the square root of both sides. All right. vfy is 0. That's why it really helps to take that extra step and rearrange the equation. And, you know, even though you're going to do your step-by-step algebra steps, you know, do it because you can make a mistake. So 2 times negative 9.8 meters per second squared times 4.5 meters. All right. So the negative times the negative is a positive. So v naught y comes out to be 9.4 meters per second. Why did I do that? Because I want to find the time. Now, there's different ways that you can find the time, but if I can avoid using the quadratic, that's what I try to do. So now I can say VFY is equal to V naught Y plus GT. So now I'm going to rearrange the equation to solve for the unknown in terms of the known. So VFY minus V naught Y over G. So this is 0 minus 9.4 meters per second over negative 9.8 meters per second squared. So the negative in the numerator cancels with the negative in the denominator, and then we have a positive value for time. So this came out to be 0.959 seconds. Now remember, we always have a foolproof way to cancel our units. So this cancels with that, this cancels with that, so 1 over a second is a second. So I see that I didn't make a mistake. And if you still want to do like a meter per second divided by a meter per second squared is a meter per second divided by a second squared over a meter, and cancel this way to end up with seconds, you do it the way that you understand it, but you have a way to always check by carrying your units through. So now we're going to find x. Oh no, we want to find VFX. So we know there's no horizontal acceleration. So x is equal to VFX times t. So VFX is equal to x over t. So it's equal to 5 meters divided by 0.95 seconds. So this comes out to be 5.2 meters per second. So remember, this is all horizontal, so this is also equal to VF, because that was VFX.
Shouldn't it be multiplied over there with the ms x squared? ms squared.
Oh, okay.